Hello and thank you very much for reading through this solution. And in this video tutorial, I'm going to be discussing with you some of the key features that I think are important to this solution. But let me just remind you that this video tutorial is not meant as a substitute for the written solution. It is only meant for a complementary material, so you'll still have to go through all of the written materials that I published on Algorand. But then this video tutorial could really highlight a couple of things that I want to emphasize. And I feel that this video tutorial will be really necessary for you to quickly get a demo up and running and sort of walk you through how you can set different parameters and then customize things yourself. So without further ado, let's just jump right into the demo. So if you've cloned this GitHub repository to your local machine, you'll probably find those files all line up in the repo already. So you've got contract.py, which is the smart contract, the main buyer, which is the utility functions for the buyer to claim interest, par values, etc. Main publisher for the publisher to issue interest tokens, par value tokens, and create the escrow account for interest transactions and par value transfers. And then if you scroll down to the bottom of this main publisher.py, you'll also find this tiny section called for demonstration purpose only. This is a demo script that I have included so that you can quickly check whether you have things set up right, and then you can do whatever you want with the rest of the project. What it does is it basically just tests out a couple of functionalities. The very first thing, as discussed in the solution, is to set up the interest and par value tokens and then to create the escrow account. This is implemented with the main pub function, which is already discussed in the solution. So after these tokens are issued and this escrow account has been set up, we want the buyer to immediately opt in this contract. We use the purchase bond utility function from main buyer. And then we have to set the closure period precisely so that the user will be able to claim the first interest right after the purchase of the bond. But here I just wanted to sort of have all things done in one go, so it takes a little bit of extra effort to do so, and I'll show you how you can configure things right. If you look to the left side of this REPL, you'll also see something that's probably not showing up in your local machine. And this VM folder is just the virtual environment, but the PyTeal folder, this is actually where all of the compiled PyTeal codes will go. Whenever a new escrow account is created, a .pyteal file will be compiled from the PyTeal template, which is here essentially just this function, escrow account. So this new escrow account is created, and then a new .pyteal file will show up here. And later in the demo, you'll see that when we create a new escrow account, a new .pyteal file will show up here. So that's basically the logic flow of this demo. And now let's just turn to the fields that you'll have to customize before this demo can be run. So first, you obviously have to pass in those 4 fields. The publisher address, the publisher passphrase, buyer address, and buyer passphrase. Notice that this is only for demonstration purpose, and you should never be passing around passphrases like this. What is suggested in production is you use something like a key manager, but here we do things like that just to keep things simple. So after all these 4 fields are set, you now turn to the closure period. As mentioned before, we want the buyer to be able to claim his or her very first interest right after the closure period. So you can see now the first coupon payment is set to closure plus 1. And then this 20 here specifies the time it needs to set up the escrow account, which is essentially the time needed for this function to run completely and submit it on the blockchain. So it's approximately 20 blocks. So right after this closure period, the first coupon payment will be valid and the user will be able to claim the very first coupon. Now to set up this field, you'll still have to pass in this current block height on the testnet. You just copy and paste from Algo Explorer. What else? Project name, this is customizable. You can call it whatever you want. Here I'm just going to be calling it Algo Test, something like that. And then payment ID, which is the stablecoin stablecoin that's accepted across this contract. Now, in testnet, we don't really have to use a stablecoin. Actually, this ID here is just an asset that I created myself, and I have previously already funded this buyer address with some of those tokens. So make sure that this asset ID that you submit here, the buyer already has a certain amount of those assets specified. Right? And then I believe all of these parameters are pretty much self-explanatory. The par value specified in amounts of payment ID, coupon, total volume, total payments, amount. Oh, okay. So amount here is the number of bond contracts that the user purchases. For sake of simplicity, just 2. Hold up is the period, is the first block after which the bond issuer will be able to claim funds out of the escrow account. Period is the time you have to wait between 2 interest payments. Span is the maximum number of blocks that an interest payment is available. So this is just exaggerated for demonstration purpose. Okay, so I don't think there's a lot to be explained over here. And now, without further ado, let's just fetch this current block height and get this demo up and running. So to do that, you simply go to Algo Explorer, and then you need this current block height number. Copy and paste it, replace it here. Let's just wait till it's 9. Okay, and then we do Python main publisher.py. Okay, up and running. It's going to be checking some of your configurations, and now you can see that it is issuing the tokens. Usually takes a while, as I said, approximately 20 blocks to do all the configurations. And now you see the interest token, the interest ID here, the par value ID here. I think we'll examine all of those fields later in Algo Explorer altogether. Creating escrow account created successfully. Activating the escrow account. Activation is essentially just a payment transaction from the publisher address to the escrow account. And then opt-in for interest token, opt-in for par value token, and payment token. You also want to transfer the interest token to the escrow account, and then transfer par value token to the escrow account. Now the setup is complete. We want the buyer to purchase the bond contract. You see now the transaction is bundling and submitting. Right. And immediately after this transaction, we want the user to claim the very first interest, and you see now it successfully committed this transaction, which means the interest payment was successful. And now we want to examine a couple of things just to make sure that this contract really implements what we intended for. So the couple of things we want to examine, maybe first let's just take a look at the interest token and par value tokens. Where is that? Here. Right? Let's just take a look at those two Algorand standardized assets and see they really do what we wanted them to do. Alright. So you see I submitted the name Algo test interest. So this is for interest token. Total supply 10,000, circulating supply 10,000. All of that. Looks good to me. And now let's check the par value token. Right, awesome. So here it is 1,000 instead of 10,000 because for interest token we're paying a total of 10 payments. So the circulating interest tokens will be 10 times the par value tokens. So this all looks good to me. What else shall we check? The escrow account. Do we want to check the escrow account? Sure, why not? Let's just check the escrow account. We want to take a look at all of the transactions. So here you can see the opting-ins of the interest tokens, par value tokens, payment tokens, this transfer of interest tokens and par value tokens from the publisher account to this escrow account. And then you can see the buyer purchasing the bond here. So this SIC is the stablecoin or the SID that I have accepted as payment. The buyer purchases 2 bonds and the par value of the bond is 10 SIC, so a total of 20 SICs will be transferred from the buyer to the escrow account. And then as return, the escrow account will be transferring 2 par value tokens to the buyer address, and then after that we can see that the 20 interest tokens will also be transferred to the buyer account. And then here I believe this is the interest payment. So for the interest payment, 2 interest tokens will be spent at each interest interval, and then this SIC, again the stablecoin accepted as payment, will be transferred from escrow account to the buyer. Let us finally take a look at the buyer address. Right? Here's the buyer address. Alright, so here's the buyer address, and I believe these 3 are the interest claim transactions. So the first transaction is transferring the interest tokens to the escrow account, and second, to validate that the user actually is entitled to claim those interest tokens, a par value token at the amount is transferred from the user to himself. And then finally, the interest payment from the escrow account to the buyer. And here you can see a little more detail here. You see the balance is 18 AIC because there's a total of 20 that's been transferred to the user, and now we've spent 2, so 18 are left. Pretty straightforward. So I believe this basically wraps up all of the demo that I would like to share with you. The par value claim is pretty much the same thing, and then the replenish of accounts that really doesn't need much of a testing. So I believe this solution provides sort of a framework for issuance of bonds with stateless contracts. And I hope that this solution and this video tutorial was useful to you, and that you are able to customize for more advanced features on your own. That's all for this demo. Thank you for your time.